And the next question. The next question is, which set G with the operation indicator does not form a group? A, whole number under addition, integers under multiplication, rational numbers under addition, real numbers except -1, under A star B is equal to A plus B plus AB. Note, a group, this one that's simply G, with an operation that's simply a dot, is a set G equipped with binary operation that satisfies 4 axioms. That means closure property, associativity, existence of identity, and the existence of that of inverse element for each group element. So when we do or simply measure the given alternatives with respect to that is whether they are satisfying this 4 axioms or not. For example, for the first one, whole number do not have an additive inverse. We know that, for example, -1 is not a whole number. We know that the additive identity here is 0, so that for each and every if it has an additive inverse for each and every element, there must exist within the same set, that's within the whole set of all numbers again, that there exists at least one element that can be added with the corresponding thing just to yield 0. So when we take 1 doesn't have an additive inverse. The additive inverse is -1, but -1 is not within this one, that's within the set of all number. Therefore, the first one cannot form a group. Integers under multiplication. Integer under multiplication do not have multiplicative inverse. For example, the multiplicative inverse of 2 is 1/2, but 1/2 is not an integer. And then there are multiple invalid groups here based on the standard definitions. So that anyways, the answer is a whole numbers under addition, or even we can take this one, and that is integers under multiplication. Next question, the value of the double integral, that is a double integral of 4xy minus y cubed dA in a region bounded by y is equal to the square root of x and y is equal to x cubed is. The alternatives are this one. So in order to find the double integral, or simply evaluate the double integral of a certain function, we have to take here, that is simply from the integral could be from 0 to 1. From 0 to 1, the integral from x cubed to the square root of x, because y is equal to x cubed and y is equal to the square root of x are given here. 4xy minus y square, y cubed, dy by dx. That is, dA can be the product of this dy and dx. So first we have to integrate this one with respect to y. When we do this, in order to integrate, or simply when we integrate the given integral with respect to y, we have to keep the second variable, that is x, as a constant. So the integral of this function with respect to y could be the integral of that simply y square, y is y square over 2, which is 2, that is 2xy square minus the integral of y cubed, y the power of 4 over 4, 1/4 times 1/4, whenever y is running from x cubed to the square root of x. Then when we substitute the upper and lower limit of integration, we have this function, that is the integral, the outer integral from 0 to 1 to x cubed to x square minus 1/4 x square minus 2x the power of 7 plus 1/4 x the power of 12. This one, that's simply the term or the function which is enclosed by the bracket, is obtained from this one by only substituting the upper limit of integration, that is radical x, and the lower limit of integration, that is x squared, for y squared and y to the power of 4. Then again integrating this one and evaluating it from 0 to that of 1 we have. That means, for example, if we start from this one, the integral of 2x squared with respect to x would be 2 times x cubed over this one, that's simply over 3 here. Okay, then 1 over 52, that's simply this one, that's simply 13 times this thing. Therefore, anyways, when we evaluate 1 over here, we have 7 over 12 minus 1 over 4 plus 1 over 52, which is equal to 55 over 156. But it is minus at 0, it is everything 0. Therefore, the double integral of this function is 55 over 156. So that the answer is A. Next, which of the following statement is false concerning any group G? The alternatives are: its identity element is unique. If it is a group, it is must be true. The inverse of every element is unique. AB inverse, the whole inverse is equal to A inverse times B inverse for all A and B an element of G. But I think this must be for a special group. A inverse is equal to A for all A an element of G. Now that the shoes and socks property stated that AB inverse is equal to B inverse A inverse. That means when we distribute this one over here, we have to info and then just interchange the position of A and that of B. Therefore, but C is only true for, that means this one, that is AB inverse is equal to inverse B inverse will hold is true only when the group, the given group is an abelian group, that is commutative group. So that the false statement, or simply probably, which may not be considered as true, could be C. So that the answer is C. Next, the value of the integral e the power of x times sine x minus cosine of x dx is this one. So the answer could be, let us take this one, that is the derivative minus e the power of x cosine of x. Then if we apply derivative of the product of the functions, this is simply the same as the product of the first function, that is the product of minus e the power of x is itself multiplied by the second one, which is minus e the power of x cos x plus the derivative of the second. The derivative of the second, that is the derivative of cosine of x is minus sine x and multiplied by this one, that is minus e the power of x, minus times minus could be positive, e the power of x sine x. Therefore, e the power of x, if we factor out e the power of x at the common factor, we have e the power of x into sine x minus cosine of x. And this matches, or simply this is identical, or simply this could be matched for the integrand perfectly. That means if the derivative of this function is exactly identical with the integrand of this function, so it means that the integral of this function is the thing that is minus e the power of x cos x plus any constant c. So that the answer could be, that is, I think it is A. A the answer. Next, let f of x is equal to x squared plus b if x is greater than or equal to 1, and minus x squared x cubed if x is less than or equal to -1, less than -1. Then find the value of b if f is continuous. This is a characteristic equation. F of x is 2x squared plus b if x is greater than or equal to -1 and minus x cubed whenever x is less than -1. So we know that a given function that is f is said to be continuous at the given point, that's simply point b, whenever b, a function is defined at this point, and also the limit of the given function is existing and equivalent to that of its functional value at b. That we know that a function is continuous at b if and only if limit of f of x when x approaches b exists and equal to f of b. But the limit of the given function, that is minus x cubed, whenever x is approaching to that of -1, is +1. And f of -1 is equal to twice of -1 square plus b is equal to 2 plus b. But there is equivalent with that simply the limit is already 1. Therefore, 2 plus b is equal to 1. This implies b is equal to -1. Therefore, the correct alternative for this equation, whenever the value of b, which can make this characteristic equation to be continuity, that b needs to be -1, so that the answer is D. Next, which of the following statement is false? Again, it is algebra question, one group theory. For any group G, for any A an element of G, there exists n an element of Z, such that A the power of n is equal to the identity element E. If G is abelian, then AB the power of n is equal to the power of n times b the power of n. Okay, anyways, A is false because it only holds 4 elements of finite order. That means if the group is an infinite order, so that the element with that is infinite groups have infinite with infinite order. Therefore, the false statement could be this one, but the rest, if G is an abelian group, then A b the power of n is equal to a the power of n b the power of n, or b the power of n times a the power of n. If a square is equal to e, then for all n element of G, then G is an abelian group, of course, and any cyclic group is abelian. Any cyclic group is an abelian group. So the answer is A. Next, solutions are independent if and only if the Wronskian is 0, not equal to 0, 1, and 2. What is the Wronskian first? We know that the Wronskian W of y1, y2, y3 of any differentiable functions is the determinant of the matrix formed by the functions and their derivatives up to order n-1. If we have n number of differentiable equations, that means. Then the Wronskian of linearly independent solution to homogeneous linear ordinary differential equation can never be 0, or simply it must be non-zero. Therefore, if the definition for, or simply the application of Wronskian is this one, so the alternative which matches with this definition could be, I think this one, that simply be, it must be non-zero, simply not equal to 0. So the answer is B. Next, the maximum of f of xy is equal to xy the power of 6 on ellipse x square over 4 plus y square is equal to y at y square is equal to okay, in order to find the maximum of this function subject to this ellipse at y square, we want to maximize f of xy is equal to x the power of xy times the power of x times y the power of 6 subject to this ellipse at y square. Here we must let's assume that let's replace a new variable y u is equal to x square and v is equal to y square. Then the constraint becomes that is the equation of the ellipse, but depending on the new variables, will be u over 4 plus v is equal to 1, which implies u is equal to 4 into 1 minus v. And substituting into the objective function x square y square is equal to uv, which is equal to 4 into 1 minus v times v, which is 4 into v minus v square. Then now let's maximize the resulting function of v, that is g of v, which is equal to 4 into v minus v square. That is g derivative of x in order to maximize it, or just to maximum value. G derivative of v is equal to the derivative of this function with respect to v, 4 into 1 minus 2v. This is already 0, then this implies this could be 0 only when v is equal to 1 over 2. This means the maximum occurs when v is equal to y square, or simply 1 over 2. 1 over 2. So the answer could be, I think it is D. At this point, that's simply 1 over 2. Question number 29. If phi is a homomorphism from group G to group G prime, then which of the following is incorrect? These are the alternatives. So the image of phi is a subgroup of the target group G prime, not the domain group G. Not the domain group G. Therefore, the incorrect one could be this one, that's simply C. But the rest are, if phi is homomorphism from group G into group prime, the phi of E, that is the image of E, could be A prime. Phi of A inverse is equal to phi of A inverse, and kernel of phi is subgroup of G. But this one is false, because the image of phi is a subgroup of target group G prime, not the domain of G. It's not the domain of G. Therefore, the answer is C. And next, which of one of the following is an integral domain? So in order to answer this question, we must be clear first what an integral domain is. You know that an integral domain is a commutative ring with unity that has no zero divisors. An integral domain is a commutative ring with unity that has no zero divisors. So that the n is said to be an integral domain if and only if n is a prime number. Because if n is an even number, that means the unity, so that the commutative ring will have zero divisors, but it will be without or simply no zero divisor whenever n is a prime number. So that 7 is the only prime number within the given alternatives. Therefore, the 7 is an integral domain. An integral domain means that is a commutative ring with unity and has no zero divisors. So that the answer is Z7, which is B. Next, dual objective function of the minimum Z is equal to 2x plus 9, such that 3x plus 5y greater than or equal to 3 and 9x plus 5y greater than or equal to 8. Here we are given the primal problem Z is equal to 2x plus 9 subject to the constraint 3x plus 5y greater than or equal to 3 and 9x plus 5y greater than or equal to 8. We know that the structure is a minimization problem with greater than or equal to. That means its square will be maximization problem. Minimization over here that greater than or equal to will be maximization. So that let's assume that U and W be the dual variables, the new variables, and we know that the dual objective function uses the right hand side of the values of the constraint. That means the right hand side value could be that is 3 for the first constraint and 8 from the second constraint. Therefore, they maximize C, which is equal to 3U plus 8W whenever you and that W are the dual variables, and 3 is the right hand value of the first constraint, and 8 is the right hand value of the second constraint. Therefore, sorry, the answer for that means from the coefficients x and y, we have 3u plus 9. It's not v, rather it is w. 9w less than or equal to 2 whenever the x coefficients are 29, and 5u plus 5v less than or equal to 9 whenever y the coefficients are 5 and 5. Therefore, whenever u and v are greater than or equal to 0 and greater than the primal constraints, the primal constraints there is no here, greater than or equal to 0 dual variables. Therefore, the answer for this could be this one, that's simply B, which is C, 3U plus 8W. That means this one. The next question. The next question says, if X is a decision variable of LPP, that is linear programming problem, and unrestricted in sign, then this variable can be converted into X is equal to X prime minus double prime of X. So as to solve the linear programming problem by simple X method, where this one. We know that the standard simplex method solves maximization linear program problem in a standard form. That is, the standard simplex requires non-negative variables. Therefore, we have to select from the given alternatives the non-negative variables. For example, here x prime greater than or equal to 0 and x double prime greater than or equal to 0. Probably this is negative, but in this case here, B, since the double prime of x is less than or equal to 0, this may have a possibility to be negative. This is also negative because of x prime is less than or equal to 0, so that the only thing that which is non-negative and satisfy the condition of standard simplex could be this one, that is A, which is x prime greater than or equal to 0 and double prime greater than or equal to 0. So the answer is A. Next question, before formulating a linear programming model, it is better to express constraints in orders or verbally identify the variables, express objectives in words, and all of the above. Just as a definition, just before formulating linear programming model, it's better to express the constraints in words, that is which constraints, how many constraints we are using, verbally identify the variables. We have to verbally identify, or simply must be clear on the identification of variables, express the objective in words. So that's all these three are very fundamental just to formulate linear program model. So all of the above could be the answer for this question. Next, in simplex, if all pivot column increase are less than or equal to 0, that is then positive. Then the type of simplex could be degenerate, alternative optimal, and bounded and visible. That is simply A. The simplex is said to be degenerate if one or more basic variables is there in the right-hand side column. If in the right-hand side column of the simplex is 0, so that could be degenerate. Alternative optimal, whenever 0 in 0 they draw Cj minus Zj is equal to 0 for non-basic variables. Unbounded, if all entries in the pivot column is less than or equal to 0, no positive entries here. And visible phase one objective, that is artificial variable remain, no basic variable solution exists. So the answer could be whenever this one are non-zero, I think it is unbounded because all entries in the pivot column are less than or equal to 0. So the answer could be that is C, which is unbounded. Okay, next. While solving an linear program defined by n variables and m equations, whenever m less than n, through simplex method, basic solutions are determined by setting n minus m variables equal to 0 and solving m equations to obtain solution for remaining m variables, provided the resulting solutions are unique. This means that the maximum number of the basic solution is what we're given here is, or what we're asked here is, we are asked just to determine the maximum number of basic solutions of this linear programming problem. We know that in simplex method, a basic solution is obtained by selecting m variables called basic variables. The remaining n minus m variables are said to be 0. So that the number of ways to choose m basic variables from n variables is this one, that's n choose m choose n, or simply just which could be written or simply calculated as n factorial over n minus m factorial times m factorial. So that the answer for this question could be, which matches with this one could be, I think it is B. B, that's simply n factorial over n minus m factorial times m factorial. The sum of the positive divisors of 48. We know that the positive divisors of 48 are, that is 1, 2, 3, 4, 6, 8, 12, up to this one, that's simply 48. All these are positives. So the sum of the positive divisors of 48 means we are asked just to determine the sum of these dividers. So that their sum could be this one, that's simply 124. 124. So that basically, or simply obviously, the answer is A. Or using divider function formula, that is sigma of n, we have prime factorization of 48 is, the prime factors are to the only to n data 3, which is to the power of 4 times 3. So that the sum of this would be to the power of the first prime factor of this natural number, the power of the exponent of this 1 plus 1 minus 1 to the power of 5 minus 1 into 3 squared, because the exponent of the second prime factor of 48 is 3, that which is 1. So that's 3 squared minus 1 over 2 minus 1 times 3 minus 1, which is equal to 31 times 4, which is 124. In both cases, the answer is the same, which is 124. So that the answer is A, which is 124. Next, which linear congruence has a solution? A linear congruence, that is 3x is congruent to 2 modulo of 6, 4x congruent to 1 modulo of 6, 2x 4 modulo of 6, 5x this one. So for a linear congruence, x is equal to b modulo of n. The solution exists if and only if the GCD of a and n divides b. That means the criteria for a linear congruence of this form, that is x equal to b modulo of n, to have a solution, or simply for the existence of a solution for this one, this linear congruence will have a solution if and only if the GCD of the coefficient of xa and n divides this one, that's simply b. So the number of solutions is equal to the GCD of an. That means if this condition is satisfied, if the linear congruence has a solution, that means, and the number of solutions of the linear congruence will be obtained by the GCD of a and that of n. That means the solution for this linear congruence will exists only when the number of solutions of this one divides b. Therefore, now let's check that. Let us check them. For example, the first one, that is 3x is congruent to 2 modulo of n. Here, the GCD of a here is 3, and this one is b, and 6 is n. So the GCD of 3 and 6. 3 and 6 is 3, and but 3 doesn't divide b, that's simply in this case 2. Therefore, no solution, or simply this 3x congruent to 2 modulo of 6 doesn't have a solution, or simply the solution doesn't exist. But if we take c, we have 2x congruent to 4 modulo of 6. The greater count factor of 2 and that of 6 is 2. 2 divides 4. That is, 4 is a multiple of 2. That means, therefore, it satisfies. And the number of equations could be, that is, the greater common factor of 2 and that of this one, that's simply 6, which is 2. So that this linear congruence will have 2 solutions. Therefore, the answer is C. Okay, octal expansion of this number. Octal means that's simply base 8. Then in order to find the given number in base 10 to another numeration system, we have to step-by-step conversion method, repeated division by 8, and taking the remainders from bottom to that of top. So let us start from this one, that is 12,345. When 12,345 is divided by 8, the quotient, that's simply the value is 1,543, and the remainder would be 1. Again, take the quotient here, divided by 8, 192, and the remainder which is obtained here is 7. Then again, take the quotient here and divide it by 8. Then we have 24, and with the remainder 0. Again, let us divide 24 by 8. Sorry, this is it is just mean 24 divided by 8, that's simply 3. The remainder here is 3, 0. And again, 3 divided by 8, 3 divided by 8, the remainder is 0. I mean, the quotient is 0, and the remainder is this one, that's simply 3. And therefore, when we take or simply take the remainders, only the remainders which are obtained at this step, at each division step, from bottom to top, we have 3, 0, 0, 7, 1. 3, 0, 0, 7, 1. Therefore, this could be 3, 0, 0, 7, 1. That simply A will be the answer for this question. Okay, next. Solve solution for 6x plus 9y is equal to 10. A0, P1, C2, and D, and infinite. You know that the given equation is linear Diophantine equation of the form x plus py is equal to c. And the given equation will have an integer solution, that is solution which are integer. That means if and only if the GCD of the coefficients of the variable divides the constant, that's c. Therefore, what we are given here is we are given the equation which is 6x plus 9y plus is equal to 10. Therefore, the GCD of the coefficients of x and y, that's got the GCD of 6 and 9 is 3. But 3 doesn't divide this one, that's simply 10. So that this will be a sufficient condition for this linear Diophantine equation not to have an integer solution. That means it doesn't have an integer solution, but the given equation will have infinite real solutions. Therefore, the answer is D, infinite real solutions. Next, which one of the following is an alternative method for linear equations? Sorry, which one of the following is an iterative method for linear equations? Corresponding Gauss-Seidel method, Gauss-Jordan method, Gauss elimination method, LU decomposition method. So let us see one by one. We know that Gauss-Seidel is an iterative method, which is successive approximation or successive iteration. Next, Gauss-Jordan is a direct method, which depends on the reduction of the coefficient matrix into an identity matrix. And Gauss elimination is also direct method, which bases on the reduction of the given coefficient matrix of the given system of linear equation into upper triangular matrix by using that of row reduction. And LU decomposition, it is also direct method, which depends on factorization method. Therefore, the only iterative method for system of linear equation could be Gauss-Seidel method, so that the answer for this question could be A. Next, Newton-Raphson method is used to find basically derivatives, roots of equations, integration, and all. Here, Newton-Raphson method is used to find roots of nonlinear equations of the form f of x equal to 0. And the formula, the iterative formula for this method, that is Newton-Raphson method, could be xn plus 1 is equal to xn minus f of xn over f derivative of xn. So the iterative method, or simply this one, that is Newton-Raphson method, used the derivative of the given function at the approximate value, but it doesn't find the derivative of the given function, or the objective of the method is just to find roots of equation. Therefore, the answer for this one is B, which is roots of equation. Next, for convergence of Newton-Raphson method, f of x times the second derivative of f at x over the square of f derivative of x must be less than 1, greater than 1, 0, and 1. We know that Newton-Raphson method convergence, or simply Raphson convergence condition. For quadratic convergence of Newton-Raphson method, the following must hold true near the approximate root, or simply near the root of the given equation. That means f of x times second derivative of f at x over the square of the derivative of x must be less than 1. The magnitude, that's simply in magnitude, it must be less than 1. That means if this condition is satisfied, so that Newton-Raphson convergence, or simply Newton-Raphson method, will converge to the exact, or simply the better approximate root of the given linear equation. So that the answer could be, that is A. Next, the value of the double integral again, that is x plus y dx dy, could be 3, 4, 2, and 1. You know that by using that of step-by-step integration, the region for integral could be first. This one, that's 0 from 0 to that of 2 is 4x, that is x must be within 0 to that of 1. And from 0 to 1, that is this line of integration, or simply could be for the outer variable, that's simply y. So that y must be 0 less than or equal to y less than or equal to 1. Therefore, now let's integrate step by step. First, if we integrate it with the inner one, that is with respect to x, that is keeping y as a constant, we have the integral of x plus y, dx from 0 to that of 2 could be, there is x squared over 2 plus yx, since we're assuming that y is a constant because we are integrating this one with respect to x. So that only the variable of integration could be x. So that this could be whenever x is running from 0 to that of 2. But when we substitute the upper limit of integration for x and 0 for and 0, so that at 2, this could be 4 over 2, that is simply 2. We have here that's simply 2y, but at 0 it's already 0, therefore we have 2 plus y, 2 plus 2i. And again, integrating the result, that is 2 plus y with respect to y, that is keeping x at the constant. We have the integral from 0 to 1, 2 plus 2y dy, which is equal to the integral of 2 with respect to y is 2y, plus this one to y could be y squared over 2, that times 2, which is y squared. Then the substituting the upper limit of integration over here, 2 times 1 is 2, and we have 1 squared, that's simply 1, and at 0 it's 0, so that 2 plus 1 will be 0, 3. Therefore, the double integral of this 1 over this region of integral is said to be 3, that's simply this one, therefore the answer is A. And next, directional derivative of f of x, y, z is equal to 4x minus 3 e the power of 3x z in direction of 1, minus 1, 4, 2 at 3 minus 1, 0 is this one. These are the alternatives. So using the directional derivative formula, we have the directional derivative of f in the direction of u is equal to the gradient of f dot vector, that's simply u, whenever this one is the unit vector mostly. But u is given to be minus 1, 4, 2, because we are asked just to find the direction derivative of this one in the direction of this at this point, and the unit vector in the direction of this one, or simply this vector, could be u, which is equal to minus 1 over square root of 1, this one, because the square root of 1 could be obtained by taking the square root of the sum of the square of minus 1 plus 4 square plus to square. Therefore, and f of x, y, z is given to be this one, then we have the gradient of this one, that is the partial derivative of f with respect to x, y, and that of z could be the partial derivative of f with respect to x could be, that is derivative of this one. We have 3, we have 4 here, and this could be e the power of minus 3x times 3z, and therefore we have 4 minus 3z times e the power of 3xz. The partial derivative of f with respect to y, because it is constant, or simply there is no y here, so that becomes 0. And the partial derivative of f with respect to z is this one. Then the gradient of f at 3 minus 1, 0 could be obtained from this one by only replacing 3 for x, minus 1 for y, and 0 for z. So when we substitute this point, that's simply this point over here, 4 minus 3 times z times e the power of 3xz, because already this one is 0, therefore the 0, so that the value of x is 4. Second one is already 0, it's 0. And the last one here, minus 3x, minus 3 times x. X index is 3. So that's 3 times minus 3 is minus 9. But e the power of 3xz, since z is zeros, it becomes e the power of 0, which is 1. 1 times minus 9 would be minus 9. Therefore, 4, 0, minus 9 is the gradient of the given function, this function, at the point 3 minus 1, 0. Therefore, the directional derivative of f in the direction of the unit vector u could be 4, 0, minus 1, that is the gradient of the given function at the indicated point, times the unit vector of the directional derivative, the directional vector, which is equal to minus 4 over the square root of 21 plus 0 plus minus 18 over 21, that is 4 times minus 1 over 21 is minus 4 over 21. 0 times this one is already 0. Minus 9 times this one is minus 18 over 21, which is equal to minus 22 over the square root of 21. Therefore, the answer for this question could be, that is A, minus 22 over the square root of 21. Next, curvature of circle with radius A is a square, the square root of A, 1 over A, and twice of A. Note, the curvature K measures how sharply a curve bends. Therefore, in the case of that of a circle, for a circle of radius A, the curvature K of a curve is given by the formula that is 1 over A whenever A is its radius, that is the radius of the circle. So that larger radius, when the radius of the given circle is large, so that its curvature, that K will be 1 over a very large number could be small. So that generally, and it is a gentler curve with small curvature. But when the radius of the given circle is very small, the curvature, or simply the curvedness of the given circle, could be sharper curved or sharper curve, and the magnitude of the curvature could be very large, or simply large curvature. That means when the curvature is large, the curve is sharp. When the curvature is small, so that the curve of the given circle will be less sharp, or simply gentler curve. So that the answer could be, that is 1 over A, which is C. This question is selecting a false statement about Jacobi versus Gauss-Seidel method, that is on numerical analysis. First one is Jacobi value modified next iteration. Jacobi requires fewer iteration used for dominant systems. Dominance is sufficient. Convergence for any initial guess. Gauss-Seidel generally converges faster than Jacobi because Gauss-Seidel method is a real modification of this one that's simply Jacobi. Therefore, this could be fasterly converges to the exact root of, or simply the better solution of the given equation plan. This one that's Jacobi, so that B, Jacobi requires fewer iteration is false. That means only Jacobi, that simply this is false. So the answer is B. But the rest are true. Last one usually gives a smaller error in numerical derivatives. Forward difference, backward difference, central difference, all the same. Truncation error in central difference is order of h square, while forward, backward difference are order of h. So usually smaller error could be a central difference is more accurate than the others. Therefore, the answer could be that is C, which is central difference. Okay, that is all what I have for today. Please don't forget just to subscribe the channel and like, comment, and share the video for your friends. Thank you.